Hello, I'm Peter Bassett of the Astronomy Roadshow Mobile Planetarium. Our lesson today is about forces, one in particular, air resistance. And okay, so we can try this at home, it's not difficult. You get two weights, something that's completely different to each other, that's not going to break. I've got one book here called The Universe, so it's bound to be heavy, and just a much smaller one here. Now they're completely different weights, and yet if I let them go, they both hit the ground at exactly the same time. It doesn't matter about their weights, it's irrelevant. The person who actually proved that once and for all was actually called Galileo. In the 1590s he rolls different sized balls, different weights balls down a ramp, and they both hit the end at the same time. If they're released at the same time, of course. Okay. Now we'll give another example here, and this is to do with air resistance this time. We've got two sheets of paper. Alright, they're both exactly the same weights, okay, they're both A3 size. If I drop them both, they just flap around, and they take quite some time to reach the ground. If I screw one of them up, right, what have I done this time? They're actually the same weight, of course, because it's smaller, doesn't mean it's lighter. What it is this time is the air resistance is now different. This is much more aerodynamic than the other one. So if I drop them both at the same time, the other one took about 3 times longer to reach the ground than the other. Simply because the air resistance is slowing down the flat piece of paper, but not the one that's screwed up. It's much more aerodynamic. So aircraft and rockets and the high-speed trains have to be aerodynamic to cut through the air. Otherwise it's very inefficient. Okay, the thing is though, the ultimate test of this air resistance business is to do with flags on the moon, for argument's sake. Okay, so on the moon there's no air at all, no air resistance either. That's what it means. There's no wind on the moon, you don't need it to make flags flap. Okay, so on the moon, of course, because there's no wind, you have to hold the flag out with another pole. Otherwise it would just droop down like this and make a boring photograph. Anyway, but if I deliberately put this in the ground, as it were, okay, this is a studio, but if this was the moon, try and screw it into the ground like this, and you whack the top with a hammer, get it into the ground like this, and it's flapping around like crazy. Okay, but if I let this go in the studio, it's surrounded by the air. Alright, the air resistance already has slowed that right down. It's not gravity, it's the air that's doing it. Alright. Anyway, so because if you're on the moon, there is no air resistance, do that and walk away from it, it will keep on flapping around. It won't slow down like it does here. Alright. There's simply no air there to actually do that. Anyway, so if people tell you that flags can't fly on the moon because there's no wind, take no notice. Because there's no wind, there's no air resistance due to that reason. Therefore, the flag will continue to move once you've got it going in the first place. But it won't go on forever because you've got another force acting upon the flag, and it's friction. Friction of the two poles. So you've got a little bit of friction here, and another look on the crossbar. So anyway, this eventually will take away the energy from the flag and slow it down. But it could take an hour because the friction here, that force, is much weaker than air resistance on Earth. Alright, so it would take a long time for it to slow down, but it would slow down the end, but it could take over an hour for that to happen. So if you see on the Apollo videos brought back, and the flags flapping around, it's quite normal, don't worry about it. There's nothing wrong with that at all. And besides, if it was windy on the moon, causing it to move, wouldn't it be rather erratic like this, if it was wind that's causing it? You'd never see it like that, ever, when there's no astronaut touching it. Alright, it's just a nice constant motion like this, simply due to momentum, as there's no air to actually slow this thing down. Anyway, just to confirm that the moon landings were correct, I've actually got, there's a book out actually that explains everything. The moon landings were genuine, and flags can fly on the moon. It's all about the Great Moon Landing Hoax, that's what it's called. And who's it by? It's by a chap called, Peter Bassett. Oh, that's me. Okay, sorry about that. Anyway, that's all about the moon landings, proving they're all correct, they're genuine, there's nothing wrong with these effects whatsoever. As this is real science I'm trying to teach, not this made up stuff that some adults come out with. Okay. Anyway, I hope you learned something, and try and experiment yourself regarding different weights, dropping them, and they should always hit the ground at the same time, apart from the air resistance bit. Alright, okay. Anyway, have a go yourselves. Good luck. Thank you.